What's going on, everyone? My name is Iceman and welcome back to DCS World. Welcome back to DCS World. Today we're going to do the training lessons for the TF-51 Delta. So let's do it. Cockpit familiarization. This lesson will take a detailed look at the TF-51D cockpit. Alright, cockpit overview, training course, let's do it.
Welcome to the cockpit overview lesson. Today, we will take a detailed look at the Mustang cockpit. You can use mouse look mode to move your view around the cockpit. To turn mouse look mode on and off, press left Alt plus C. Throughout this lesson, pressing the spacebar key will initiate the next consecutive step once instructions for the current one are complete. Press the spacebar key when you are ready to begin.
Wow, look at this cockpit, dude. It's not bad at all. Wow, look at this. Not bad. Alright, let's do it.
The cockpit is configured in a standard layout, with the instrument panel positioned on the front dash, a center-mounted control stick, a throttle quadrant on the left side, and various aircraft system controls on the left and right panels. With the exception of the flaps control handle, which is located in the bottom left corner of the cockpit, most of the indicators and controls are well organized and easy to read and reach.
Yeah.
Moving on to the instrument panel, the upper left corner houses the remote indicating compass. The compass unit is installed inside the left wing and transmits magnetic readings electrically to the cockpit indicator. Using a remote compass avoids the magnetic effects caused by armor plating around the cockpit, experienced by a standard magnetic compass. The remote indicating compass includes a heading needle, which shows the current heading, and a desired heading needle, which can be turned using the indicator knob to set a desired course reference on the indicator. To turn the knob, you can simply roll the mouse wheel over it.
Nice.
To the right of the remote indicating compass is a standard clock. The winding knob can be used to set the time. Doing so requires pulling the knob out with the left mouse button, then rolling the mouse wheel over the knob to rotate it.
Okay.
The suction gauge indicates the amount of pressure in inches of mercury being generated by the engine vacuum pump. Vacuum pressure is used by a number of vital instruments, including the flight indicator, bank and turn indicator, and the directional gyro. A suction reading above or below normal means the readings of these indicators are unreliable. Next is the manifold pressure indicator. This is one of the primary instruments used in flight, and together with the tachometer or engine RPM indicator is your main reference of engine power. The manifold pressure indicator shows gas pressure inside the engine induction system prior to entering the cylinders. Like the suction gauge, the indication is in inches of mercury. Manifold pressure is set using the throttle handle, while engine RPM is set using the propeller control lever, also on the throttle quadrant. On the left side of the middle row of the instrument panel is the airspeed indicator, which shows an indicated airspeed in miles per hour, mph. The red line on the indicator marks the maximum permissible airspeed of 505 miles per hour. It's important to remember that maximum permissible indicated airspeed is reduced as altitude increases. For example, it is 400 mph at 20,000 feet and 300 mph at 30,000 feet. In the left center of the instrument panel is the directional gyro, which shows current heading. The instrument can be caged and the heading adjusted manually by pushing in and rotating the indicator knob. In the center right of the instrument panel is the flight indicator, which shows the aircraft's roll and pitch attitude relative to the horizon. The indicator is limited to 60 degrees in pitch and 100 degrees in roll. The instrument can be caged or uncaged using the caging knob in the lower right corner of the indicator. The horizon level can be adjusted vertically using the pitch adjust knob. To the right of the flight indicator are two temperature gauges, the coolant temperature gauge above and the carburetor air temperature below. It's important to monitor these instruments in flight, as temperatures rising above normal may lead to serious engine problems, such as detonation and pre-ignition.
Oh shit.
On the right side of the middle row of the instrument panel is the tachometer. This instrument indicates engine speed in revolutions per minute, RPM. The pilot controls engine speed using the propeller control lever on the throttle quadrant. A propeller governor system automatically adjusts propeller pitch angles to maintain the RPM set by the pilot. Typical RPM settings in flight will be between 1,800 and 3,000 RPM. Moving to the bottom row of the instrument panel, the left corner houses the altimeter. The altimeter shows barometric or pressure altitude using a three-needle system. The shortest needle shows altitude in tens of thousands of feet, the middle needle in thousands of feet, and the longest needle in hundreds of feet. The indicator knob is used to adjust the sea level reference pressure in inches of mercury to ensure an accurate altitude reading over a desired location where the sea level air pressure is known. Next is the bank and turn indicator, primarily used to maintain coordinated flight and minimize side slip. The vertical needle of the instrument indicates turn rate, and the slip ball indicates side slip or side skid. In flight, the pilot maintains the ball's center by using stick and rudder controls or aileron and rudder trim. Flight trim is very sensitive to changes in engine power and airspeed, so constant attention must be paid to the bank and turn indicator in order to fly as efficiently as possible. To the right is the rate of climb indicator, which shows the climb rate in thousands of feet per minute.
Okay.
Further to the right is the accelerometer, or G-meter. This indicator shows the G-load factor experienced by the aircraft, as well as two additional needles that show the maximum and minimum G-loads attained since the instrument was last reset. The instrument includes a reset button used to reset the needles to zero. Finally, on the very right is the engine gauge. This instrument includes three indicators: the oil temperature gauge, oil pressure gauge, and the fuel pressure gauge.
Uh, right. Yeah.
Moving below the instrument panel, the engine control panel includes a number of important engine controls. These include supercharger blower switch, sets the supercharger to low, high, or automatic blower modes. Normally this should be set to auto. The jewel light indicator lights up when the supercharger kicks into high blower mode. Fuel booster switch turns the fuel booster pumps on and off. Oil dilute switch, used to dilute the oil with gasoline, which may be necessary when starting in cold temperatures. Starter switch, used to turn the engine prior to ignition during startup. Primer switch, used to feed fuel to the engine through the fuel primer system during startup. To the right are the two landing gear warning lights. These indicate safe or unsafe states of the landing gear. For example, the unsafe red light will be on if the gear doors are open but the landing gear is unlocked.
Mhm.
Adjacent to the landing gear warning light is the parking brake handle. Setting the parking brake requires the following steps. Pull out and hold the parking brake handle. Fully depress and release the brakes. Release the parking brake handle. Releasing the parking brake only requires a press of the brake pedals.
Hmm.
On the right side below the instrument panel are the oxygen indicators, the oxygen flow indicator, and the oxygen pressure gauge. The oxygen flow indicator features a blinker that opens and closes as the pilot inhales and exhales on-demand oxygen. The oxygen pressure gauge shows the amount of oxygen remaining in the O2 tanks in pounds per square inch, psi. A normal reading is 400 psi. Just below the instrument panel is the front switch panel, which includes a variety of important controls. Ignition selector switch selects the left, right, or both magnetos to operate the engine ignition system. Cockpit light switch turns on and adjusts the cockpit floodlights. Horn silence button silences the AN/APS-13 rear warning radar alarm. Below the front switch panel is the fuel control panel. This includes the fuel shutoff valve, used to open and close the fuel flow, and the fuel selector valve, used to select the fuel tank used to feed the engine. Correct fuel tank selection is important in flight to maintain a balanced aircraft. To the right of the fuel control panel are the hydraulic pressure gauge and the landing gear fairing doors emergency release handle. The landing gear fairing doors emergency release handle can be used to release the hydraulic pressure and mechanical locks holding the gear doors closed. This will open the fairing doors and allow the landing gear to fall down under its own weight. Slight rolling of the aircraft from side to side can be used to ensure the gear locks in place prior to landing. Normal pressure for the hydraulic system is 800 to 1100 psi. The surface control lock is used to lock the control stick in place when the aircraft is parked. Left-clicking over the pin locks the stick in a forward position, which leaves the tail wheel unlocked and allows the aircraft to be towed and turned easily. Right-clicking on the pin locks the stick in the neutral position, which leaves the tail wheel limited to 6 degrees of turn.
Okay.
Moving to the left side of the cockpit, the throttle quadrant dominates the forward section. The throttle quadrant includes the throttle handle, the propeller control lever, and the mixture control lever. In addition, 2 friction locks are mounted on the assembly and can be used to stop the movement of the throttle handle or the mixture and propeller control levers. The throttle handle features a microphone switch button used to activate transmission over the VHF radio. Moving back from the throttle quadrant, the radiator air control panel includes switches to operate the coolant and oil radiator flap doors. These are usually kept in automatic, but can be opened and closed manually when necessary. This panel also includes the landing light switch and the left-hand fluorescent light rheostat switch, which controls instrument backlighting on the left side of the cockpit. 3 trim wheels are used to set the aileron, rudder, and elevator trim. Take off with 5 to 6 degrees of right rudder trim to help compensate for engine torque. Trim settings in flight may vary depending on flight conditions. The 2 handles toward the left rear of the cockpit control airflow to the engine induction system. The ram air control handle controls whether air is ingested through the main intake under the nose or filtered intakes on either side of the nose. Filtered air is used when icing of the intake develops. The hot air control handle opens a vent door in the engine compartment to allow warm air to enter the carburetor. This can be done below 12,000 feet when icing of the carburetor is a danger. Probably the most awkward control in the cockpit is the flaps control handle in the bottom left corner. The flaps can be set from 0 to 47 marked 50 degrees in 10-degree increments. The landing gear control handle is also on the left side. The handle is pulled in and moved up or down to raise and lower the landing gear as desired. The gear should only be moved when it's locked in either the up or down position. Now moving on to the right side of the cockpit, we have 2 canopy controls. The canopy is rolled open and closed by turning the canopy hand crank. The red handle is the emergency canopy release. When pulled, this will unlock the canopy and it will fly off into the slipstream. The oxygen regulator is used to control oxygen flow to the pilot's mask. The oxygen diluter lever, marked with yellow stripes, is used to set normal diluted oxygen or 100% oxygen. The red emergency valve is a separate backup oxygen line and can be used to bypass the regulator. The recognition light's keying switch is used to flash the recognition lights installed on the other side of the right wing tip when they are set to key mode on the electrical panel. The lights turn on for as long as the keying switch is held down and off when it is released. The electrical control panel includes switches for battery and generator power, pitot tube, and external lighting. In addition, the right-hand fluorescent light rheostat switch controls the backlighting for instruments on the right side of the cockpit. The electrical control panel also includes an important indicator, the ammeter. This shows current output of the generator in amperes. Maximum permissible output is 100 amperes. The ammeter does not show battery current. Finally, the electrical control panel also includes a circuit breaker bump plate. This can be pressed in to reset all the circuit breakers in case one or more of them gets overloaded and pops out.
Oh shit.
Further back from the electrical control panel is the AN/APS-13 Rear Warning Radar, or RWR. This device sounds an alarm when an object is detected behind the aircraft to warn the pilot of a possible threat approaching from the rear. Next is the SCR-522 VHF radio, used for communication with flight members and air traffic controllers. The radio features 5 channels, the frequencies for which are preset and cannot be changed in flight. You should consult your mission briefing prior to starting a flight to ensure your radio is set up to contact ATC towers in your vicinity. The remaining radio systems, including the homing adapter, IFF transponder, and Detroller range receiver, are not functional in this aircraft.
Am I hearing? Oh shit, a plane. Civilian.
Let's now take a look at the fuel gauges. You may need to twist your head around the cockpit a little to see them. You can press left Alt plus C to enable mouse view mode, and then hold down the mouse wheel while moving the mouse to move your head around the cockpit. The gauges for the left and right main tanks are located on the floor to either side of the seat.
Fuck yeah, dude.
Finally, the area under the seat also houses cockpit environmental controls, including windshield defrosting and cockpit heating and cooling. This concludes the cockpit overview lesson. Next time, we'll learn how to start her up.
Fuck yeah, dude. Alright, engine start procedure. In this lesson we'll practice starting the TF-51D from the ramp. Alright, start up.
Welcome to the startup lesson. Press the spacebar key to begin.
First, before we begin, I'm going to close the canopy. Alright, close the canopy. See what we look like. Fuck yeah. Closed canopy. Alright, let's do it.
The engine start sequence is not very complicated. We will move around the cockpit clockwise, starting on the left side to configure the aircraft for engine start. Let's begin with the flaps control handle, positioned to the rear bottom left side of the cockpit. For a normal takeoff, flaps are not usually lowered. However, 15 to 20 degrees of flaps can be used when a minimum run takeoff is required. Set the flaps control handle all the way up to the up position. To do this, you can either click and drag the handle with the mouse or press left shift plus F command repeatedly until it is all the way up. Note, the flaps won't actually come up until the engine is running and there is sufficient pressure in the hydraulic system to raise them. Now set the carburetor induction system for normal operation by moving the cold air control handle all the way forward to the ram air position and the hot air control handle all the way forward to the normal position. Next, set the coolant and oil radiator air control switches to the auto position for automatic operation of the coolant and oil radiator flap doors. To do so, left-click on the auto switch positions. Don't forget to close the switch covers after. Adjust the trim tabs to prepare for takeoff. Set rudder trim to 5 degrees right. Elevator trim can be left neutral. Aileron trim remains neutral.
Trim to 5 degrees. Oh, that's aileron trim. Shit.
On the throttle quadrant, Ensure the propeller RPM lever marked P is set all the way forward to increase and the fuel mixture lever marked M is set to idle cutoff. Set the throttle handle about 1 inch forward from the full back position to slightly open the throttle butterfly valve and allow air to flow to the engine. If you don't have a throttle controller, the plus and minus keys on the keyboard numpad can be used to move the throttle handle. Moving to the engine control panel on the front dash, turn on the fuel booster pump by setting the fuel booster switch to the up position by clicking over the switch. Select the left and right magnetos to provide power to the engine ignition system by setting the ignition switch to both. On the fuel control panel, ensure that the left wing tank is selected for fuel consumption by checking that the fuel selector valve is set to the main tank LH position. Open the fuel shutoff valve by clicking on it to set it to the on position. Let's set the parking brake to make sure we remain stationary when the engine begins to pull. You may want to open the controls indicator by pressing right control plus enter to monitor the positions of your flight controls, including the brakes. Setting the parking brake takes a few steps. First, pull out and hold the parking brake handle by clicking and holding it. Next, while continuing to hold the parking brake handle, fully press the brake pedals by holding down the W key. Continuing to hold the parking brake handle, release the wheel brakes by releasing the W key.
Oh shit.
Now release the parking brake handle to set the parking brake. If done correctly, the parking brake handle should remain in the pulled out position. We'll now move on to the electrical control panel on the right side of the cockpit. Set the battery switch to the up position to provide electrical power. Also, set the generator switch to the up position to prepare the generator to take over once the engine is running over 1500 to 1700 RPM.
Alright.
Click and hold the primer switch on the engine control panel for about 1 second to feed some fuel to the engine. When starting in cold temperatures, up to 4 seconds of prime may be necessary. We are now ready to attempt an engine start. To do so, first press and hold the starter switch to operate the starter and begin turning the engine. As the engine begins to catch, move the fuel mixture control lever on the throttle quadrant to the run position by right-clicking on it once. If you aren't able to start the engine successfully, return the fuel mixer lever to idle cutoff by left-clicking and repeat the process starting with priming the engine. Note, the engine starter can be easily overheated. The starter should not be used for more than 4 20-second attempts to start, with 15-second intervals, followed by a 5-minute cooling off period.
Alright, let's do it. You ready? Let's do it. Oh shit. There we go.
Good start. Now we need to make sure the engine is running smoothly without any indications of a problem. Use the RPM gauge and adjust the throttle to run the engine at about 1200 to 1300 RPM. Monitor the engine gauge to check the oil pressure to reach at least 50 psi and the oil temperature to reach at least 40 degrees Celsius. Check the suction gauge to make sure it is showing a normal suction reading of 3.75 to 4.25 inches. Press the spacebar key to proceed.
Okay.
Check the hydraulic pressure gauge to make sure it is reading a normal pressure of 800 to 1100 psi. Check the oxygen pressure gauge to make sure it is reading a normal pressure of 400 psi. Press the spacebar key to proceed. Continue to idle the engine at 1000 to 1200 RPM until ready to taxi or perform a pre-flight check. Remember to release the parking brake before taxiing. To do so, fully depress and release the wheel brake's W key. This concludes the engine start lesson. Well done.
Why isn't it this idle? Why isn't this at idle? Look at it. This should be at idle. See what we look like on the outside. We got a helicopter. Look at that. That's fucking awesome. That's pretty sick. Alright. Not bad at all. Alright. Quit. Taxi. System will practice taxiing the TF-51D. Fuck yeah. Alright. Briefing. Taxi.
Welcome to the taxi lesson. Press the spacebar key to begin.
Fuck yeah. Look at that, we got new paint. Fuck yeah.
As with most other aircraft configured with a tail-dragging undercarriage, taxiing in the P-51 can be tricky. Forward visibility is obstructed by the nose, and it doesn't take much to nose over into the ground. To maintain awareness of the area ahead, the aircraft is taxied in a zigzag or S pattern, turning it from side to side as it rolls forward. You can move your head position to either side in the cockpit to peek around the nose. To do so, press left Alt plus C to enable mouse view mode, and press and hold the mouse wheel while dragging the mouse left and right. Alternatively, you can use the commands right control plus right shift plus num 4 and right control plus right shift plus num 6 to move your head from side to side. Press the spacebar key to proceed. Another important element to keep in mind is the position of the control stick. When the stick is held aft of center, pulled toward the pilot, the tail wheel is limited to 6 degrees of rotation to either side. This is the standard taxi and takeoff position of the stick. It helps maintain directional control, but limits the turning radius of the aircraft. When the stick is pushed forward of neutral, the tail wheel is unlocked and becomes free swiveling. In this case, the rudder pedals do not control the tail wheel. This makes it possible to perform tight turns, but can be very tricky to control as the aircraft rotation can be sudden and violent depending on speed, applied brakes, engine power, and rudder position. Press the spacebar key to proceed. When taxiing over a smooth and level surface, such as this runway, very little engine power is required. It's also best to minimize the use of brakes to prevent unnecessary wear and heating. Hot brakes can easily ice over after takeoff as the aircraft climbs into colder temperatures at altitude. Press the spacebar key to proceed. Press right control plus enter to open the controls indicator so you can monitor the position of your flight controls. Pull the control stick aft of center and hold it there to keep the tail wheel locked for taxiing. To practice taxi control, we will use a lead car to take you through a short taxiing course. The car is now waiting in position to your left. Press the spacebar key when you are ready to begin. The car will now drive forward at about 10 mph. Add a little power to begin moving forward. Use the numpad plus and minus keys to control the throttle. Use the Z and X keys to control the rudder pedals to turn left and right. Use the W key to depress the wheel brakes as required. Zigzag from side to side as you follow the car through the course. Try to stay between 100 and 300 feet from the car. Don't worry, if you get too far behind, it will stop until you catch up. Don't get too close either, or the driver will panic from fear of being turned into mincemeat and will stop.
Now I'm at idle. Well, idle now. Like literally
The
idle.
car will now turn onto the taxiway to the right.
Fuck yeah, dude. Yeah, I'm at idle. I'm not even playing with the throttle anymore. Once I get going, it just keeps going.
The car has stopped so you can catch up. The car is moving again.
Look at that. Whoa.
The car will now turn right to come around onto the taxiway leading back to the runway. The car has stopped so you can catch up. We'll stop here for a moment. Moving on, we'll now make a left onto the runway. The car is moving again.
Whoa. But be careful.
We'll now make a right turn onto the apron area to turn around to face the runway again. This is a tight space and will require some care. You may need to unlock the tail wheel to make this turn by pushing the stick forward. When the tail wheel is unlocked, use differential braking to control your turn. Press left control plus W to use the left wheel brake, and left alt plus W to use the right wheel brake.
Oh, it's gonna be a hard turn. Whoa.
The car will stop here. See if you can pull up next to it.
Nice. I. 'Cause. 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 'C
This concludes the taxi lesson. Nice job.
Fuck yeah. I did it. Takeoff guided practice. In this lesson, we'll practice taking off in the TF-51D with help of the instructor. Takeoff training course.
Welcome to the takeoff lesson. Press the spacebar key to begin.
Alright, let's do it.
The 51 is generally very controllable in takeoff, but the powerful engine and large propeller spinning at the front do require careful use of the rudder in order to maintain a straight course down the runway. A right rudder trim of 5 to 6 degrees is a standard takeoff setting and is usually sufficient to maintain directional stability in the takeoff run. A normal takeoff is performed at takeoff power, which is 61 inches of manifold pressure at 3,000 RPM. However, to minimize controllability issues while practicing, we will take off at a reduced power setting of about 50 inches of manifold pressure. Press the spacebar key to proceed.
Alright.
Your primary instruments during the takeoff run will be the airspeed indicator on the left side of the instrument panel and the manifold pressure indicator on the right side. Once in the air, we will use the turn indicator and the rate of climb indicator to maintain a desired flight path. Press the spacebar key to proceed. The first key element of a successful takeoff is a gradual onset of power. You cannot just slam the throttle forward. The torque effects of a sudden burst of power are very likely to run you off the runway and into the grass with devastating results. The other key element is the tail lift. As the aircraft accelerates toward 100 miles per hour, the tail will lift itself off the ground, unless held down with some stick back pressure. You can perform a takeoff without a tail lift by simply holding the stick back to maintain a 3-point attitude until the plane flies itself off the ground. Most pilots, however, prefer to let the tail rise up to continue accelerating while running on the front wheels before lifting off into the air. Press the spacebar key to proceed. The takeoff starts with the stick held back to keep the tail wheel locked for a controlled ground run. To perform a tail lift, neutralize the stick as speed approaches 100 miles per hour. Be careful to avoid lifting the tail too early by pushing the stick forward. The changes in pitch angles occurring during the tail lift cause significant directional instability, which is more difficult to control at slower speeds. Careful rudder input will be required to maintain heading as the tail lifts. You may need to alternate a bit of right and left rudder input before stabilizing for the liftoff. Press the spacebar key to proceed. Flaps are not used in a normal takeoff. 15 to 20 degrees of down flaps are used when a minimum run takeoff is required. Press right control plus enter to open the controls indicator so you can monitor the position of your flight controls. To prepare for the takeoff run, set the rudder trim to about 5 degrees right. Click and drag the rudder trim tab control wheel. On the throttle quadrant, make sure the RPM lever is set all the way forward to increase. If not, press and hold the page up key to set it. Hold down the wheel brakes using the W key.
Okay.
Using the numpad plus and minus keys, control the throttle to set the manifold pressure to about 30 inches. Keep the stick pulled somewhat aft of neutral to keep the tail wheel locked. Whenever you're ready, release the wheel brakes to begin the takeoff run.
Alright, let's go.
Use the rudder or Z and X keys to maintain your heading down the runway. Gradually add power to set about 50 inches of manifold pressure. Neutralize the stick to lift the tail. Easy on the rudder. Gently pull back on the stick to take off. Watch the turn indicator and use your rudder and aileron control to maintain your takeoff flight path by keeping the ball in the center. Retract the gear with the G key. Monitor the landing gear warning lights to make sure the gear retracts and locks successfully. Lights extinguished. Quickly check the engine gauge to make sure the oil temperature and pressure are showing normal readings. Also check the coolant temperature gauge for a normal reading. Reduce power to maximum continuous by first setting 46 inches manifold pressure and then reducing RPM to 2700. Good approximate climb speed is 170 mph. Set a desired climb rate using the rate of climb indicator and trim the aircraft to maintain the flight path. As you continue to climb, monitor the instruments to make sure the aircraft is operating normally. This concludes the takeoff lesson. Well done, pilot.
Fuck yeah. Alright. Takeoff solo practice, not going to do that. Landing. System will practice landing the TF-51 using visual approach followed by the shutdown procedure. Alright, landing.
Welcome to the landing lesson. Today we will practice flying a visual approach pattern, followed by the engine shutdown procedure. If you're having trouble hearing my instruction over the engine noise, turn down the world and in-cockpit sound sliders in the options menu. Take a moment to stabilize the aircraft at level flight. Set the throttle to about 30 inches of manifold pressure to keep the speed around 250 miles per hour. Follow the coastline as we fly northbound. Press the spacebar key when you are ready to begin. The Mustang is not equipped with any modern precision approach systems, such as ILS. This means landings are performed using a visual approach pattern. In this lesson, we'll use a standard military overhead pattern. An overhead pattern consists of the following basic elements. Entry into the pattern on the upwind leg, where the aircraft is flown along the runway parallel to the landing course. The crosswind leg, where the aircraft is turned 180 degrees to take the downwind leg, using the turn to bleed off any excess speed. The downwind leg, where the aircraft is flown along the runway in the opposite direction of the landing course and is prepared for landing. The base leg, where the aircraft is turned another 180 degrees while descending to take the final approach. The final approach, where the aircraft is flown down a steady glide path past the runway threshold to the touchdown point. I've included an image with the mission briefing showing an example of the overhead approach pattern. To open the briefing, press left Alt plus B. Press the space bar key to proceed. The lengths and altitudes of a pattern may vary. For this practice mission, we will assume a typical pattern of entry at 1,000 feet above ground level and holding that altitude on the upwind and downwind legs. Base leg, descending to 600 feet toward the final approach point. A normal 3-degree glide slope from the final approach point, starting at 600 feet of altitude and 2 nautical miles away from the runway. Press the space bar key to proceed. The airspeeds flown in the pattern depend on the aircraft. For the 51D, the pattern speed is no greater than 200 miles per hour. Because the landing gear and flaps can only be lowered at speeds below 170 miles per hour. One of the advantages of the overhead pattern is that it allows you to bleed off any excess airspeed in the crosswind turn before settling down on the downwind leg and dropping the gear and flaps for final approach. Final approach is flown at 120 miles per hour and touchdown speed is 90. Press the space bar key to proceed. Landing is one of the most difficult and dangerous elements of flying, especially in an airplane like the 51, where a powerful engine and large propeller in the nose of the aircraft pull a massive amount of torque. At low speeds, the aircraft is very sensitive to power changes, and it's easy to get into trouble by mishandling engine and aircraft controls, in particular at low altitudes when there's little time to react. Once we enter the pattern, be careful to avoid large throttle movements and handle the controls carefully to maintain controlled and stable flight. Press the space bar key to proceed. Before entering the pattern, set the engine RPM to 2,700. should see the airfield ahead, a few miles east of the coast. You should also see a pattern of green gates arranged in the air to help guide you through the overhead pattern all the way down to the runway. The pattern entry gate is the large one, positioned 1,000 feet above the runway threshold. Take a heading for the entry gate, which will put you on the upwind leg over the runway, heading away from the coast.
I hate the overhead pattern. I'm so bad at it.
You're approaching the pattern. Level off at 1,000 feet and follow the gates to fly the pattern.
Can't believe I'm doing this shit.
Good job entering the pattern. You are now on the upwind leg. Keep the power down and monitor your airspeed and altitude. The next leg will be the crosswind turn, taking 180 degrees degrees left to put you on the downwind leg. Use the turn to bleed off any excess speed so that you're below 200 mph on the downwind leg.
Alright, here we go.
You're now on the downwind leg. Maintain airspeed around 160 mph and altitude at 1,000 feet. Lower the landing gear by pressing G. Watch the landing gear warning lights panel to make sure you get the green light. Press the F key twice to set the flaps to 20 degrees down.
Oh, that's some that popped up.
The next gate will be the start of your base leg, leading you through a descending left-hand turn toward the final approach point. Control your airspeed to make sure it stays below 160 mph for final approach. You're now lining up for final approach. Press the F key 3 more times to lower the flaps all the way down. Maintain 120 mph on final. Minimize side slip and trim for a steady approach. If you find yourself getting into trouble, add a little power, then raise the gear and flaps to climb out and go around. Speed looks good. Keep it around 120 on final. As you approach the threshold, prepare to reduce power and flare the aircraft by gently pulling the stick back. You want a gentle touchdown at about 90 mph. Carefully reduce power and continue pulling the stick back for a gentle flare. Try to make a 3-point landing to avoid a bounce.
Not
Use
bad.
careful Z or X rudder commands to roll down the center of the runway. Do not use the wheel brakes unless you have to. Set throttle to idle power at 1000 RPM. Continue to roll to the next available taxiway to the right. Press and hold left control plus C to open the canopy.
Not bad at all.
Slow down and take the taxiway to the right. Turn left and park in one of the parking spaces. We'll now shut down the aircraft. Let's first set the parking brake. Note that in cool weather you should give the brakes time to cool prior to setting the parking brake. Pull and hold the parking brake handle by clicking on it and holding the mouse button down. Continue to hold the parking brake handle and press the wheel brakes down by holding down the W key. Now release the wheel brakes by releasing the W key. Release the parking brake handle to set the parking brake. Set propeller RPM to full increase with the page up key and idle the engine at 1500 RPM. Turn off the fuel booster pumps by setting the fuel booster switch to off. Open the fuel and coolant radiator flap doors by holding each switch in the open position. Then set the switches to off. Set the trim tabs to neutral. Raise the flaps by dragging the flaps control handle up or pressing left shift plus F5 times. Set the fuel mixture to idle cutoff to shut down the engine. Turn off the magnetos by setting the ignition switch to off. Turn off the fuel shutoff valve. Turn off the pitot heat, generator cutoff, and battery cutoff switches on the electrical control panel. Turn off all cockpit and external lights that may be on. Pull the landing gear emergency release handle to release hydraulic pressure. Lock the controls. Left-click on the latch to lock the controls in a stick-forward position for towing, or right-click on the latch to lock the stick in the neutral position with the tail wheel locked. This concludes the landing lesson. Nice job.
Fuck yeah. We did it. We fucking did it. TF-51. Alright, that's all for this part, guys. If you'd like to smash the like button like a badass, leave a comment. I'll see you guys next time. Farewell.